How do you raise a 114,000-ton ship that's laying on its side? That was the monumental challenge facing engineers after the Costa Concordia disaster. You've likely heard the story of the cruise ship that grounded off the coast of Giglio Island in 2012 after an irresponsible decision by an arrogant captain. But after the dust settled, authorities had an enormous task ahead of them: figure out what to do with the wreck. The sheer scale of the wreck, its precarious position, and the delicate marine environment made this one of the most complicated and expensive salvage operations in history. In this video, we'll explore the incredible, complex, and often hazardous process of raising the Costa Concordia from its watery grave, and the ingenuity and sheer determination it took to get it done. Welcome to Shipwreck History. Launched in 2006, the Costa Concordia was a floating city, capable of carrying thousands of passengers in luxurious style. The vessel was designed to offer guests an unforgettable experience at sea, combining elegant design with advanced navigation and safety systems. The ship boasted luxury accommodations, multiple restaurants, a casino, and a theater. As a symbol of Italian craftsmanship and maritime prowess, it quickly became a popular choice for Mediterranean cruisers, showcasing Italy's vibrant culture and scenic coast. On January 13, 2012, the Costa Concordia set sail from Civitavecchia, near Rome, on what was supposed to be a routine cruise. Shortly before 10 p.m., a navigational error and fatal miscalculation by the captain brought the ship too close to the island of Giglio. A collision with underwater rocks ripped a gash in the hull, a fatal wound that would seal the ship's fate. The impact would flood the engine room, crippling the ship. Captain Schettino delayed declaring emergency and evacuation orders, and crew initially told passengers they were only experiencing a loss of electricity. Once it was clear that the ship was listing heavily, panic ensued as passengers scrambled to evacuate into lifeboats. Many were stranded on board to await rescue. The captain, after his disastrous decision and poor response to the emergency, abandoned his ship to save himself, leaving the panicked passengers behind. As emergency responders worked to evacuate passengers and contain the unfolding disaster, rescue boats and helicopters saved the majority of Costa Concordia occupants. Tragically, 32 lives would be lost in the disaster, most of the trapped in the hull of the ship as it capsized. With the human cost painfully evident, authorities shifted their focus to the daunting challenge of stabilizing and salvaging the massive ship, setting the stage for an unprecedented maritime recovery operation. Rescue and body recovery efforts began immediately on January 13, 2012, as teams scrambled to secure the wreck site and recover victims. In the ensuing weeks, reports emerged that looting occurred before Italian authorities could fully secure the area, complicating the initial investigation. The official inquiry into the Costa Concordia tragedy commenced right after the sinking and continued with extensive forensic examinations and salvage planning into 2013. Concurrently, Captain Schettino was arrested on January 14, 2012, and his trial proceeded separately in the Italian legal system, culminating in his conviction in 2015 for manslaughter, causing a maritime accident, and abandoning his ship. After the Costa Concordia settled off the coast, listing precariously against the rocky seabed off the island of Giglio, the first critical phase of the salvage operation was to prevent the massive vessel from slipping further into deeper waters. In the weeks following the grounding, a multidisciplinary team of marine engineers, salvage experts, and government officials launched a thorough investigation into the Costa Concordia wreck. Using detailed surveys, 3D mapping, and underwater inspections, they assessed the ship's condition and its precarious position on the rocky reef, quickly realizing that the salvage would be one of the most complex ever attempted. Initial estimates projected a cost of over €1 billion and required the coordinated efforts of hundreds of skilled workers over 10 months. But as the investigation unfolded, it became clear that the challenges were even greater than anticipated. These findings laid the groundwork for an unprecedented salvage operation that would push modern engineering to its limits. Engineers and salvage experts immediately mobilized a team to anchor and stabilize the ship, knowing that any further movement could jeopardize the entire recovery process. They began by carefully securing the ship with a network of heavy-duty cables and chains, strategically fastened to robust, pre-installed anchors along the shoreline and on the seabed. These cables were connected to key structural points on the hull to counteract the forces of gravity and the relentless pressure of the waves. Detailed calculations were made to determine the precise tension required on each cable, ensuring that the enormous weight of the listing vessel was evenly distributed and that its tilt would not worsen. In this painstaking process, salvagers also had to contend with the vessel's unstable position and the unpredictable Mediterranean conditions, which demanded continuous monitoring and adjustments. This initial stabilization was not just a temporary fix. It laid the foundation for the subsequent, more complex salvage phases, such as constructing a false bottom and executing the parbuckling maneuver. By anchoring the Costa Concordia securely, the team ensured that the ship would remain in a controlled position, allowing them to plan the next steps with greater precision and safety. In the next phase, engineers turned their attention to one of the most innovative aspects of the salvage operation, constructing a stable underwater platform, or false bottom, to support the Costa Concordia during the parbuckling process. To achieve this, teams deployed thousands of heavy-duty grout bags, large fabric sacks filled with a quick-setting cement mixture, and custom-designed shock-absorbing mattresses beneath the ship's hull. In addition, caissons were welded to the ship's side, providing extra stabilization and ensuring that the vessel's weight was evenly supported during the complex maneuvers ahead. These components were meticulously arranged in a precise grid pattern to distribute the immense weight of the vessel evenly across the platform. The grout bags provided a rigid, supportive base while the flexible mattresses acted as cushions, absorbing the tremendous forces generated during the ship's rotation. This carefully engineered false bottom not only allowed salvage teams to gradually pump out water from under the vessel, but also ensured that the structural stresses during the parbuckling maneuver were managed safely. In essence, the creation of this underwater foundation was a critical and groundbreaking step, one that showcased the ingenuity and technical prowess required to undertake one of the most complex salvage operations in maritime history. The next step was the parbuckling phase. Parbuckling is a salvage technique used to rotate a stranded or a listing vessel back to an upright position, a maneuver that was central to the Costa Concordia recovery. For this operation, engineers employed an array of advanced equipment, heavy-duty strand jacks and cables, and buoyancy-boosting sponsons. The process began with attaching cables at strategic points on the ship, anchored to both the shoreline and the seabed. Strand jacks then applied controlled incremental force to these cables, gradually twisting the vessel from its listing position towards an upright position. Engineers meticulously monitored every phase of the rotation with real-time sensor data to ensure the vessel's structural integrity was maintained throughout the process. Over several days of precise adjustments, this delicate interplay of forces transformed the Costa Concordia from a wreck dangerously tilted on a rocky reef into a stabilized, upright vessel, setting the stage for the subsequent refloating and towing operations. Once the Costa Concordia was rotated to an upright position, the next critical step was to boost its buoyancy. Engineers attached sponsons and caissons to the starboard side, and additional sponsons to the port side of the vessel's hull. These sponsons were secured with heavy-duty bolts and reinforced welds along key structural points to ensure even distribution of lift. Their precise placement was crucial. They needed to counterbalance the ship's enormous weight without imposing additional stresses on its compromised structure. With the sponsons in place, the refloating process began. Air was gradually pumped into these devices, replacing the water inside and causing them to inflate steadily. This controlled inflation, combined with simultaneous dewatering from the ship's compartments, increased the overall buoyancy of the vessel in a measured manner. As the sponsons expanded, they lifted the Costa Concordia incrementally off the engineered false bottom, a process that required continuous monitoring and delicate adjustments to prevent further damage. Over several hours, this careful strategy succeeded in refloating the vessel, a pivotal moment in the salvage operation. Once the Costa Concordia was refloated, the salvage team prepared for the next monumental phase, towing the vessel to the port of Genoa. A fleet of specially equipped tugboats, each chosen for its high towing capacity and reliability in rough seas, was assembled for the job. Engineers meticulously planned the tow, mapping out a precise route that accounted for tidal variations, weather conditions, and the ship's vulnerable structure. Constant communication between tug operators and the salvage command center ensured that the tension on the tow lines was maintained within strict limits to prevent further damage. Over the course of several days, the Concordia was slowly and carefully hauled from the treacherous waters off Giglio Island into the safer and more controlled environment of the Ligurian Sea. Upon reaching Genoa, the focus shifted to dismantling the vessel, a process that was as technically challenging as it was environmentally sensitive. The ship was moved to a dedicated dismantling yard, where teams of engineers and environmental specialists set to work. The operation began with the systematic removal of hazardous materials, including residual fuel, lubricants, and asbestos, all handled in strict compliance with European Union ship recycling guidelines. Every part of the ship was then catalogued, from its massive steel framework to the intricate systems that once guided it through the Mediterranean. This painstaking process, which spanned several months, not only marked the final chapter in the tumultuous history of the Costa Concordia, but also set a new standard for environmentally responsible ship recycling and maritime salvage operations. From the initial stabilization to the precise parbuckling, every stage of the Costa Concordia salvage operation pushed the limits of modern engineering. Advanced techniques like constructing an underwater false bottom, fixing buoyancy-enhancing sponsons, and employing strand jacks to rotate the vessel were executed with surgical precision. Hundreds of experts from various fields coordinated their efforts to transform a listing 114,000-ton ship into a recoverable asset, overcoming challenges that had once seemed insurmountable. This operation has redefined maritime salvage, establishing new procedures and safety standards that have since influenced numerous recovery projects worldwide. The achievement stands as a milestone in engineering, demonstrating that with innovation, collaboration, and meticulous planning, even the most daunting obstacles can be overcome. If you enjoyed this video, don't forget to like and share, and subscribe to our channel for all things shipwrecks. Let us know in the comments what shipwrecks you want us to cover next. Until next time, keep exploring.